Video for milestone 2 of CEMScript Catalyst project. As milestone 1, our goal was to create interfaces for our project. And in current milestone, our goal was to implement them. We provide two implementations, on-chain and off-chain. We can show how they works on example of simple auction, one of our two main examples. This class instance is the only part which CEMScript user should write manually. It specifies logic of the script. That is params, state, stages, and transitions. And after that, user can specify how state machine for this script works. From this specification, our SDK derives on-chain and off-chain implementation. If user is not happy with our on-chain implementation, they could implement it themselves for performance or other considerations. For example, one could adapt existing Bluetooth or Plutarch code or even icon code to use with CEMScript API by instantiating CEMScript compiled with their own code. Off-chain code implementation uses same interfaces which was present as part of first milestone. Now we have implementation of these interfaces for layer 1. This means that one could query or send transactions in real blockchain. As part of milestone 3, we will provide additional implementation targeting emulator to test scripts locally fast. We can see how this API works in our tests. First, we have low-level API, which is essentially the same as Atlas or other application backend works. As part of this interface, we could ask for different parameters of blockchain. We can look for different UTXOs present, and we can send transactions specified manually. This is not much different from different application backends. So our innovation is more higher level interface, which works on level of specific CEMScripts. We are showing how to send transactions from auction use case. For that, we create params. We specify params for this auction, which are static and do not change. And after that, they can perform any transition which is available to current state. For example, we can use create transition, which creates auction, which is signed by seller user. After that, we could query state of auction, which is present on blockchain, and see that it's indeed in the state that they accept. Submit and check includes finding necessary inputs for these transactions, constructing necessary outputs for these transactions, checking it, and sending it into blockchain network. This is what differentiates our approach from different application backends. We can see, for example, of Ghidra auction, which is a prototype for one of our main examples. One could see that we have models in folder on-chain, and we have models in folder TX. That is because for each script, we need to first write on-chain implementation, and then we should write off-chain implementation, which mirrors on-chain implementation. But it could also introduce subtle bugs. As you may see, we need to write a function for querying current state of script, and we need to write functions for performing each of transitions. For performing transition, we need to find necessary inputs, we need to check what they do exist and provide correct errors if they do not. And then we need to create transaction. This could introduce subtle bugs in which transaction works in some cases and doesn't work in another. In this scenario, Cardano provides usually not very usable errors to debug the issue. In our approach, user always get a correct transaction. If user provides not correct transition, they get error on the level of our API. You may see this in our tests. If user tries to apply transition which is not applicable in current state of script, they get error. In this case, it states like that. If they apply transition which can be applied in the current state, but is anyways not correct, they get error as well. In case if script is not existent or it is of different params, user should get error as well, but this is not very much covered in current implementation. It would be covered more in depth, like errors related to time and errors related to quick and chain changes as part of milestone 3.